Well, your first job was at Denny's. They now have a booth dedicated to you. What was your fondest memory of working?
My second job was AMD, by the way. Is there a booth dedicated to me there? I'm just kidding.
But how did you convince the most sought-after investor in Silicon Valley to invest in a team of first-time founders building a new product for a market that doesn't even exist?
I didn't know how to write a business plan. He said, I have no idea what you said. That's one of the worst elevator pitches I've ever heard. And then after that, he said, if you lose my money, I'll kill you.
Jensen, this is such an honor. Thank you for being here. In honor of your return to Stanford, I decided we'd start talking about the time when you first left. You joined LSI Logic, and that was one of the most exciting companies at the time. You're building a phenomenal reputation with some of the biggest names in tech, and yet you decide to leave to become a founder. What motivated you?
Chris and Curtis. I was an engineer at LSI Logic, and Chris and Curtis were at Sun. And I was working with some of the brightest minds in computer science at the time. Chris and Curtis said one day that they'd like to leave Sun, and they'd like me to go figure out what they're going to go leave for. So we hung out at Denny's, which is, by the way, my alma mater, my first company. My first job before CEO was a dishwasher, and I did that very well. And so anyways, we got together, and it was during the microprocessor revolution. This is 1993. In 1992, when we were getting together, the PC revolution was just getting going. It was pretty clear the microprocessor was going to be very important. And we thought, why don't we build a company to go solve problems that a normal computer can't? And so that became the company's mission, to go build a computer, the type of computers, and solve problems that normal computers can't. And to this day, we're focused on that. And if you look at all the problems that in the markets that we opened up as a result, things like computational drug design, weather simulation, materials design, these are all things that we're really proud of. Robotics, self-driving cars, autonomous software we call artificial intelligence. We drove the technology so hard that eventually the computational cost went to approximately zero. And it enabled the whole new way of developing software, where the computer wrote the software itself, artificial intelligence as we know it today. And so that was it. That was the journey.
Yeah.
Thank you all for coming.
Well, these applications are on all of our minds today. But back then, the CEO of LSI Logic convinced his biggest investor, Don Valentine, to meet with you. He is obviously the founder of Sequoia.
Yeah.
Now I can see a lot of founders here edging forward in anticipation. But how did you convince the most sought-after investor in Silicon Valley to invest in a team of first-time founders building a new product for a market that doesn't even exist?
I didn't know how to write a business plan. So I went to a bookstore, and back then there were bookstores. In the business book section, there was this book, and it was written by somebody I knew, Gordon Bell. It's a very large book, and the book says, How to Write a Business Plan. And that was a highly specific title for a very niche market. And it seems like he wrote it for like 14 people, and I was one of them. And so I picked up this book. It's like 450 pages long. Well, I never got through it, not even close. I flipped through it a few pages, and I go, you know what? By the time I'm done reading this thing, I'll be out of business. And so instead of writing the business plan, I just went to talk to Wilf Corrigan. He called me one day and said, hey, you left the company. You didn't even tell me what you were doing. I want you to come back and explain it to me. And so I went back and I explained it to Wilf. Wilf, at the end of it, he said, I have no idea what you said. And that's one of the worst elevator pitches I've ever heard. And then he picked up the phone and he called Don Valentine. He says, Don, I'm going to send a kid over. I want you to give him money. He's one of the best employees LSI Logic ever had. And so the thing I learned is you can make up a great interview. You could even have a bad interview, but you can't run away from your past. And so have a good past. Try to have a good past. And in a lot of ways, I was serious when I said I was a good dishwasher. I was probably Denny's best dishwasher. I planned my work. I was organized. I was mise en place. And then I washed the living daylights out of the dishes. And then they promoted me to busboy. I was certain I'm the best busboy Denny's ever had. I never left the station empty-handed. I never came back empty-handed. I was very efficient. And so anyways, eventually I became, a CEO. I'm still working on being a good CEO. But
You talk about being the best. You needed to be the best among 89 other companies that were funded after you to build the same thing. And then with 6 to 9 months of runway left, you realized that the initial vision was just not going to work. How did you decide what to do next to save the company when the cards were so stacked against you?
Well, we started this company called For Accelerated Computing. And the question is, what's it for? What's the killer app? And this is what Sequoia funded. The first great decision was the first killer app was going to be 3D graphics. And the application was going to be video games. At the time, 3D graphics was impossible to make cheap. And the video game market was $0 billion. So you have this incredible technology that's hard to commoditize and commercialize. And then you have this market that doesn't exist. That intersection was the founding of our company. And I still remember when Don, at the end of my presentation, one of the things he said to me, which made a lot of sense back then, it makes a lot of sense today. He says, startups don't invest in startups, or startups don't partner with startups. And his point is that in order for Nvidia to succeed, we needed another startup to succeed. And that other startup was Electronic Arts. And then on the way out, he reminded me that Electronic Arts' CTO is 14 years old and had to be driven to work by his mom. And he just wanted to remind me that's who I'm relying on. And then after that, he said, if you lose my money, I'll kill you. And that was my memories of that first meeting. But nonetheless, we went on the next several years to create the gaming market for PCs. And it took a long time to do so. We're still doing it today. And invent a new way of doing computer graphics so that what was $1 million is now $300, $400, $500 that fits in a computer. So we had to create technology, create markets. The idea that a company would create technology, create markets defines NVIDIA today. People call it a stack, an ecosystem, words like that. But that's basically it. At the core, for 30 years, what NVIDIA realized we had to do is in order to create the conditions by which somebody could buy our products, we had to go invent this new market. And it's the reason why we were early in autonomous driving. It was the reason why we're early in deep learning. All these different areas, we're trying to create the market while we're creating the technology. And then Microsoft introduced a standard called Direct3D. And that spawned off hundreds of companies. And we found ourselves a couple of years later competing with just about everybody. The technology we invented 3D graphics with, the consumerized 3D with, turns out to be incompatible with Direct3D. So we started this company, we had this 3D graphics thing, $1 million thing, we're trying to make it consumerized. And so we invented all this technology. And then shortly after, it became incompatible. So we had to reset the company or go out of business. But we didn't know how to build it the way that Microsoft had defined it. I remember a meeting on a weekend, and the conversation was, we now have 89 competitors. I understand that the way we do it is not right, but we don't know how to do it the right way. Thankfully, there was another bookstore, and the bookstore is called Fry's Electronics. I don't know if it's still here. And it was sitting right there. The OpenGL manual, which would define how Silicon Graphics did computer graphics. And so I had a couple $100. I bought 3 books. I took it back to the office, and I said, guys, I found it, our future. And I handed it out. I had 3 versions of it. I handed it out. Had a big, nice centerfold. The centerfold is the OpenGL pipeline, which is the computer graphics pipeline. And I handed it to the same geniuses that I founded the company with. And we implemented the OpenGL pipeline like nobody had ever implemented the OpenGL pipeline. And we built something the world never seen. And so a lot of lessons are right there. That moment in time for our company gave us so much confidence. And the reason for that is you can succeed in doing something, inventing a future, even if you were not informed about it at all. And it's kind of my attitude about everything now. When somebody tells me about something and I've never heard of it before, or if I've heard of it, don't understand how it works at all, my first thought is always, how hard can it be? And it's probably just a textbook away. And then go back to first principles and ask yourself, given the conditions today, given my motivation, given the instruments, the tools, given how things have changed, how would I reinvent this whole thing? How would I design it? How would I build a car today? Would I build it incrementally from 1950s and 1900s? How would I build a computer today? How would I write software today? Does it make sense? And so I go back to first principles all the time, even in the company today, and just reset ourselves. Because the world has changed. And the way we wrote software in the past was monolithic, and it's designed for supercomputers, but now it's disaggregated. And how we think about software today, how we think about computers today, how we think, just always cause your company, always cause yourself to go back to first principles, and it creates lots and lots of opportunities.
Yeah, the way you applied this technology turns to be revolutionary. You get all the momentum that you need to IPO, and then some more, because you grow your revenue 9 times in the next 4 years. But in the middle of all of this success, you decide to pivot a little bit the focus of innovation happening at Nvidia based on a phone call you have with this chemistry professor. Can you tell us about that phone call and how you connected the dots from what you heard to where you went?
Remember, at the core, the company was pioneering a new way of doing computing. Computer graphics was the first application. But we always knew that there would be other applications. And so image processing came, particle physics came, fluids came, so on and so forth. And then one day we invented programmable shaders, which made all forms of imaging and computer graphics programmable. That was a great breakthrough. And so we created this thing called CG. And so I think it was 2003 or so. C for GPUs. It predated CUDA by about 3 years. The same person who wrote the textbook that saved the company, Mark Kilgard, wrote that textbook. And so CG was super cool. We wrote textbooks about it. We started teaching people how to use it. And then several researchers discovered it. A couple of doctors at Mass General picked it up and used it for CT reconstruction. So I flew out and saw them and said, "What are you guys doing with this thing?" And so I realized that there's some evidence that people might want to use this. Gave us, incrementally more confidence that we ought to go do this. This form of computing could solve problems that normal computers really can't, and reinforced our belief and kept us going.
And that seems to be a theme throughout your leadership at Nvidia. It feels like you make these bets so far in advance of technology inflections that when the apple finally falls from the tree, you're standing right there in your black leather jacket waiting to catch it. How do you find the conviction?
Always seems like a diving catch. Always does seem like a diving catch. You do things based on core beliefs. We deeply believed that we could create a computer that solves problems normal processing can't do. That there are limits to what a CPU can do. There are limits to what general purpose computing can do. And then there are interesting problems that we can go solve. The question is always, are those interesting problems only, or can they also be interesting markets? Because if they're not interesting markets, it's not sustainable. And NVIDIA went through about a decade where we were investing in this future and the markets didn't exist. So how do you continue with all of the people around you, all of the amazing engineers that are there creating this future with me, all of your shareholders, your board of directors, all your partners, you're taking everybody with you, and there's no evidence of a market. That is really challenging. Before a market exists, you still need early indicators of future success. There's a phrase called key performance indicators. I find KPIs hard to understand. What's a good KPI? Gross margins. That's not a KPI. That's a result. You're looking for something that's an early indicators of future positive results, okay? And as early as possible. And the reason for that is because you want that early sign that you're going in the right direction. You want to decouple the result from evidence that you're doing the right thing. That's how you solve this problem of investing into something that's very far away and having the conviction to stay on the road is to find as early as possible the indicators that you're doing the right things. And so start with a core belief. Unless something changes your mind, you continue to believe in it and look for early indicators of future success.
What are some of those early indicators that have been used by product teams at NVIDIA?
All kinds. I met some people that needed my help on this thing called deep learning. At the time, I didn't even know what deep learning was. And they needed us to create a domain-specific language so that all of their algorithms could be expressed easily on our processors. And we created this thing called cuDNN. We created a language, if you will, domain-specific language for that, like the OpenGL of deep learning. They needed us to do that so that they could express their mathematics. And they didn't understand CUDA, but they understood their deep learning. And so we created this thing in the middle for them. You know, these researchers had no money. And this is kind of one of the great skills of our company, that you're willing to do something, even though the financial returns are completely non-existent, or maybe very far out, even if you believed in it. We ask ourselves, is this worthy work to do? Does this advance a field of science somewhere that matters? We find inspiration not from the size of a market, but from the importance of the work. Because the importance of the work is the early indicators of a future market. And nobody has to do a business case on it. Nobody has to show me a P&L. Nobody has to show me a financial forecast. The only question is this important work? And if we didn't do it, would it happen without us? Now, if we didn't do something and something could happen without us, it gives me tremendous joy, actually. And the reason for that is, could you imagine the world got better, you didn't have to lift a finger? That's the definition of ultimate laziness. And in a lot of ways, you want that habit. And the reason for that is this: if somebody else can do it, let them do it. We should go select the things that if we didn't do it, the world would fall apart. You have to convince yourself of that. That if I don't do this, it won't get done. And if that work is hard and that work is impactful and important, then it gives you a sense of purpose. Does that make sense? And so our company has been selecting these projects. Deep learning was just one of them. And so we convinced ourselves this could change everything. And anyhow, that's an example.
So these selections that you've made, they've paid huge dividends, both literally and figuratively. But you've had to steer the company through some very challenging times, like when it lost 80% of its market cap amid the financial crisis because Wall Street didn't believe in your bet on ML. In times like these, how do you steer the company and keep the employees motivated at the task at hand?
When your share price drops 80%, it's a little embarrassing, okay? You just want to wear a t-shirt that says, "Wasn't my fault." But even more than that, you don't want to get out of your bed, you don't want to leave the house. All of that is true. But then you go back to just doing your job. I woke up at the same time, prioritize my day in the same way. I go back to, what do I believe? What are the most important things? Keep the company focused back on the core. Do you believe in it? Did something change? The stock price changed, but did something else change? Did physics change? Did gravity change? Did all of the things that we assumed, that we believed, that led to our decision, did any of those things change? Because if those things change, you got to change everything. But if none of those things change, you change nothing. When things are challenging, it's not easy to be in front of precisely the people that you care most about. And the reason for that is because, could you imagine a company meeting our stock price just dropped by 80%? And the most important thing I have to do as the CEO is this: to come and face you, explain it. You're not sure why, you're not sure how long, how bad, and you just don't know these things. But you still gotta face all these people, and you know what they're thinking. Some of them are probably thinking we're doomed. Some people are probably thinking you're an idiot. And you know that they're thinking those things, but you still have to get in front of them and do the hard work.
They may be thinking of those things, but yet not a single person of your leadership team left during times like this. And in
They're
fact,
unemployable. I'm just kidding. I'm surrounded by geniuses. Nvidia is well known to have singularly the best management team on the planet. This is the deepest technology management team the world's ever seen.
Your employees say that your leadership style is very engaged. You have 50 direct reports. You encourage people across all parts of the organization to send you the top 5 things on their mind. And you constantly remind people that no task is beneath you. Yeah. Can you tell us why you've purposefully designed such a flat organization? And how should we be thinking about our organizations that we design in the future?
No task is beneath me, because remember, I used to be a dishwasher, and I mean that. I used to clean toilets. I cleaned a lot of toilets. I've cleaned more toilets than all of you combined. And some of them you just can't unsee. You can't show me a task that's beneath me. Now, I'm not doing it because of whether it's beneath me or not beneath me. If you send me something and you want my input on it, and I can be of service to you, you're empowering people all over the place. And so that's how I see it. If you send me something, you want me to help review it, I'll do my best, and I'll show you how I would do it. In the process of doing that, of course, I learned a lot from you. Is that right? You gave me a seed of a lot of information. I learned a lot. And so I feel rewarded by the process. It does take a lot of energy sometimes because in order to add value to somebody and they're incredibly smart as a starting point, you have to at least get to their plane. You have to get into their headspace. And that's really hard. And that takes just an enormous amount of emotional and intellectual energy. CEO should have the most direct reports by definition because the people that reports to the CEO requires the least amount of management. It makes no sense to me that CEOs have so few people reporting to them. Our ability to reason through complicated things, lead other people to achieve greatness, inspire, empower other people, support other people, those are the reasons why the management team exists in service of all of the other people that work in the company. And so you should create the conditions by which they could do their life's work, which is my mission, which means you have to be informed. And the best way to be informed is for there to be as little layers of information mutilation, right, between us. Nvidia has 30,000 people. We're the smallest large company in the world. We're a tiny little company. But every employee is so empowered, and they're making smart decisions on my behalf every single day.
I do want to now address the topic that is on everybody's mind, AI. Last week, you said that generative AI and accelerated computing have hit the tipping point. So as this technology becomes more mainstream, what are the applications that you personally are most excited about?
You have to go back to first principles and ask yourself, what is generative AI? What happened? What happened was, first of all, we digitized everything. That was like, for example, gene sequencing. You digitize genes. But what does it mean? That sequence of genes, what does it mean? We've digitized amino acids. But what does it mean? We digitize words. We digitize sounds. We digitize images, videos. We digitize a lot of things. But what does it mean? We now have the ability to, through a lot of studying, a lot of data and from the patterns and relationships, we now understand what they mean. Not only do we understand what they mean, we can translate between them. And so for obvious things, you could caption video to text, that's captioning, text to images, Midjourney, text to text, ChatGPT, amazing things. And so we now know that we understand meaning and we can translate. The translation of something is generation of information, and all of a sudden you take a step back and ask yourself, what is the implication in every single layer of everything that we do? What it means is that the way that we process information fundamentally will be different in the future. That's what Nvidia builds, chips and systems. The way we write software will be fundamentally different in the future. The type of software we'll be able to write in the future will be different, new applications. And then also, the processing of those applications will be different. What was historically a retrieval-based model where information was retrieved based on some recommender system algorithm, in the future, some seed of information will be the starting point. We call them prompts, as you guys know. And then we generate the rest of it. And so the future of computing will be highly generated. We're having a conversation right now. Very little of the information I'm conveying to you is retrieved. Most of it is generated. It's called intelligence. And so in the future, our computers will perform in that way. It's going to be highly generative instead of highly retrieval-based. Then you go back and you got to ask yourself, what industries will be disrupted? Will we think about networking the same way? Will we think about storage the same way? Would we be as abusive of internet traffic as we are today? Probably not. So you can go through the entire industrial spread and ask yourself what's going to get disrupted, what's going to be different, so on and so forth. And that reasoning starts from what is happening. What is generative AI? Foundationally, what is happening? Go back to first principles with all things. You asked the question, and I forgot to answer it. The way you create an organization, by the way, someday, don't worry about how other companies' org charts look. You start from first principles. Remember what an organization is designed to do. The organizations of the past where there's a king, CEO, and then you have all these royal subjects, the royal court, and then you keep working your way down. Eventually, they're employees. Well, the reason why it was designed that way is because they wanted the employees to have as little information as possible because their fundamental purpose of the soldiers is to die in the field of battle. To die without asking questions. You guys know this. I only have 30,000 employees. I would like none of them to die. I would like them to question everything. Does that make sense? And so the way you organized in the past and the way you organize today is very different. Second, the question is, what does Nvidia build? An organization is designed so that we could build whatever it is we build better. And so if we all build different things, why are we organized the same way? It doesn't make any sense. You build computers, you organize this way. You build healthcare services, you build exactly the same way. It makes no sense whatsoever. And so you have to go back to first principles. Just ask yourself, what kind of machinery? What is the input? What is the output? What are the properties of this environment? What is the forest that this animal has to live in? You're the CEO. Your job is to architect this company. That's my first job, to create the conditions by which you can do your life's work. And anyways, may I take one more question?
Well, we have some rapid-fire questions for you as a view from the tradition.
Okay. I was trying to avoid that.
Well, your first job was at Denny's. They now have a booth dedicated to you. What was your fondest memory of working?
My second job was AMD, by the way. Is there a booth dedicated to me there? I'm just kidding.
If there were a worldwide shortage of black leather jackets, what would we be see you wearing?
Oh no, I've got a large reservoir of black jackets. I'll be the only person who is not concerned.
You spoke a lot about textbooks. If you had to write one, what would it be called?
I wouldn't write one. You're asking me a hypothetical question that has no possibility of
That's fair. And finally, if you could share one parting piece of advice to broadcast across Stanford, what would it be?
Have a core belief, gut check it every day, pursue it with all your might, pursue it for a very long time, surround yourself with people you love, and take them on that ride. So that's the story of Nvidia.
Jensen, this last hour has been a treat. Thank you for spending it.
Thank you very much.